Hi, everyone. Welcome to another segment on Chapter 10 on Monopoly. In this segment, we're going to dive into calculating the profit using the total approach and using the marginal approach, which is exactly what we did when we did perfect competition. And these are exactly the same concepts, except now, as you know, the monopolist faces the entire demand curve, and the demand curve is downward sloping. And therefore, the marginal revenue curve is downward sloping, and it falls out underneath the demand curve and intersects the x-axis at half the distance that the demand curve intersects the x-axis. So let's take a look at this. So we'll look at a table first and then the graph, and we'll start with the total approach to looking at profit maximization. Now, this should look exactly the same as what you remember seeing for perfect competition. So here we've got our quantity increasing from 1 to 10, and the price is average revenue, of course, but notice that that's decreasing. So this is the first difference to perfect competition. Again, that the price is lowered by the monopolist in order to sell more. They have price control. And then, of course, we just multiply quantity times price to get our total revenue. They give us total cost. We subtract the two, and we get total profit and loss. So in the first case, it's minus 20, then minus 10, and then 0. Of course, that's a break-even quantity because the total profit is 0. That's economic profit is 0. We keep going and we find another 0, and that's another break-even quantity, of course, at an output of 8. Total revenue here equals the total cost, just like it did up here. Total revenue is 54 and total cost was 54. So those are our break-even quantities. We continue down the total profit side and we find that our maximum profit is 18, and that happens to be at an output of 6. So 6 is our profit maximizing quantity, and we're making a profit of 18. Okay, well, let's take a quick look at the graph. Notice the only thing that's changed here is that price is decreasing all the way along, but everything else, the conceptually, is exactly the same as what we did for perfect competition. Now the graph definitely looks a bit different. Let's take a peek at that. We're considering total profits here. Well, of course, those are maximized when we're looking at the total approach. They're maximized when TR is greater than TC at the maximum amount. So when TR minus TC is its greatest distance. So what we're going to do is plot the total revenue. It's the blue line here that goes up and twists to the right. And it's curved like this because price and quantity are both changing. And then we plot the total cost curve, which should be a little more familiar. We've looked at these before. And it twists up and then comes back and then twists up again. And that's again due to the law of diminishing returns. So the first thing we should see is where the total cost and total revenue cross is where they're equal. And those should be an output of, here's 3 and there's 8. Those are break-even quantities, just like from the table. Nothing surprising there. And the total profit is going to be where we have the largest distance between total revenue and total cost, and that is occurring right there. That's down at a quantity of 6. That's our profit maximizing output. So we can look at the table or the graph to get these critical points, the break-even points and the profit maximizing point. Now, if we go one step further and subtract total cost from total revenue, that is the profit function. So down here, this line here is actually TR minus TC. That is the profit function. And if we subtracted the two, we'd see here's 0. We've got minus 30 losses going up to a maximum profit of 18. But more importantly for us, that occurs at an output of 6. So we can find our profit maximizing point just by taking the profit function, which is total revenue minus total cost, and plotting it. Oh yeah, and what's more, if we find out where profit is 0, right here, TR minus TC is 0, here's the number 0, that's at an output of 3, just like up here. And it occurs again right here at an output of 8, just like up here. So we can find our profit maximizing curve, our profit maximizing points or in this case, 1 point, of course, and our break-even points on the graphs as well as the tables. So let's look at the total profits using the marginal approach. And just to convince yourself that this isn't any more complicated really than the perfect competition approach, just look, if I ask you, what are the break-even points? What are the break-even quantities? Well, you should be kind of thinking, well, we go to the total profit and find out where we're making zero economic profit. That's where our total revenue is going to be equal to total cost, or our average revenue is going to be equal to average cost, right? Same thing. And that's at an output of 3. And the other one is an output of 8. So those are our break-even quantities. Okay, and before looking at the details of this table at all, what's the profit maximizing quantity? Well, using the total approach, it's kind of easy. You come down and you find where total profit is a maximum, and it's right there. Pick the second one, and that's at an output of 6. So we already know the answers. This looks a little bit like perfect competition so far, but it's not. Let's go into greater detail now. We still have the same quantity going from 1 to 10. We see that price, which is equal to average revenue, of course, starts at 20 and drops. That's because in order to sell higher quantity, the monopolist has to lower the price. We still get total revenue by going price times quantity, and we still have total cost. Only now we're doing it slightly different. We're looking at the marginal approach. So the first thing we do is we have to calculate average total cost. So we take total cost of 40 divided by the quantity. Remember, average cost is just total cost divided by quantity. And we do that all the way down, and we find that the average cost falls to a minimum. That's at 12, and then turns around and rises again, just like we know average cost does from way long ago in our cost chapters. Our marginal cost, we know that's the change in total cost or change in total variable cost. Remember, they're the same thing. The change is the same thing. So our change in total cost from 40 to 48 is 8, and we divide by our change in quantity from 1 to 2, which is 1. 8 divided by 1 is a marginal cost of 8. Okay, perfect. And we do that all the way down to calculate marginal cost. We see that it falls and then it rises. Okay, so when we want to look at this and figure out what is our break-even point using the average approach or the marginal approach, which is the same thing, for our break-even, we need to find where average revenue equals average total cost. So I just go along here and find out there's my average cost of 18, and average revenue is price, right? So there's my average revenue or my price of 18. And where my average revenue just equals my average cost, of course, that means we're breaking even. So there's the condition. Average revenue equals average cost, and that's at a break-even quantity of 3. So we keep going down these two columns. So say we haven't calculated this total profit column. We go down the price or average revenue and average cost column and see where they're equal again. Are you equal here? No. 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 Are you equal here of 13 and here of 13? So average revenue equals average cost there, and that's an output of 8. Okay, so that's another break even. Yep, right there. Total profit is 0. Average revenue minus average cost is 0. Average revenue equals average cost at break-even points. Now the profit maximizing point, nothing's changed here. We still have to find where marginal revenue equals marginal cost. We know that that's our criteria. Same in perfect competition, same in monopoly, same in every market structure we look at. Only before, in perfect competition, we said price was the same as marginal revenue. So we just looked for price equaling marginal cost. Here, price is not the same as marginal revenue. Here's our price column. I'll just go down it. And here's our marginal revenue column. They're different in monopoly, but we still use the same profit maximizing condition where MR equals MC. So I go down my MR column and I go down my MC column and I try and find where they're the same. 10 and 20, nope. 8 and 18, nope. So on, down to 10 and 10. And yes, right here, where we have a marginal cost of 10, it just equals a marginal revenue of 10. So that's got to be our profit maximizing output of 6, right? So using the average in red and marginal in purple conditions, we can find our break-even quantities and our profit maximizing point. And that's more useful to us. That's the one we use more often, this marginal approach to finding the profit maximizing position and also finding our break-even points. Just as a side note, I want to reiterate that this marginal revenue column, and particularly here where marginal revenue was 10, that's very different than the price of 15 over here. Price and average revenue are 15 here at this output of 6, but marginal revenue is 10 because they're not the same under the monopoly. Okay, so now we're looking at the break-even and the profit maximizing points using average and marginal costs for the monopolist, but we're doing it under a graph. So break-even is the same old break-even. We find out break-even where average revenue equals average cost. So where is my average revenue and where is my average cost? Well, my average cost is easy to see here. Here's my average cost line. Average cost curve or average total cost curve, it's the same thing. But where's my average revenue line? And that is the demand curve. Or if I could really use a term we shouldn't use too much, I can call it the price line, because you get price off of that demand curve. Price and average revenue are the same thing. But the condition is just find where average revenue equals average cost, just like we did in the table. Well, they're the same because average revenue comes off the demand curve, and they're the same because average revenue comes off the demand curve. And in both cases, they cross the average cost curve. So your break-even outputs occur at this amount. This is supposed to come down, and I think it's supposed to be a 3. It's drawn a little crooked, and this comes down, and it's the 8. So our break-even points are where average cost equals average revenue. Just, of course, that's the same condition whether it's perfect competition or monopoly, only it looks a bit different in monopoly because the demand curve slopes down. Same condition though, and same results. So let's find out the profit maximizing position. And we remember that that's where marginal revenue equals marginal cost. Right here, I'll draw it in a different color so it's a little bit clearer. That's where marginal revenue equals marginal cost. Now this graph is drawn a bit funny, but here's my marginal revenue line. It's below the demand curve. There's marginal revenue, and there's marginal cost. So I need to find the point where they're equal, and that's right there. It's actually a little to the left of the dotted line they've accidentally drawn. So marginal revenue equals marginal cost right there. We come down, our profit maximizing output is 6. That's the best production number to be at. Whether or not we're making profits or losses, that's still the best one to be at. So from this here, output of 6, we need to find the price that's being sold. We go up to the demand curve or the price line to find the price of 15 or the average revenue. Average revenue is also equal to price of 15. At this output of 6, I just go up to the average cost curve right there and come across, and I see my average total cost is 12. So I'm making profits because my price is greater than average cost. The monopolist first finds the profit maximizing output of 6, and then from there goes up to the demand curve or the price line to figure out what price the monopolist could charge in the market. Well, this demand curve says they could charge 15. And the monopolist is very happy with that because at an output of 6, their best output, their average cost is only 12. So we can go down and calculate the profit for the monopolist is going to be average revenue minus average cost. Notice it's exactly the same formula as we used in perfect competition, because you calculate profits the same way. Average revenue minus average cost times quantity. Well, my average revenue, well, that's my price. It's 15. My average cost, we said, is 12. Okay, 15 minus 12 is 3. That's just my average profit. I have to multiply by 6 because that's how many units I'm producing. So 3 times 6 is 18. That's my profit on this graph and in this particular situation. So it looks pretty similar to perfect competition, but when you slope that demand curve down, then you get that marginal revenue curve that flops out of the bottom. But after that, the analysis is all exactly the same as perfect competition was. Now keep in mind that in this particular case, we're showing economic profits because where marginal revenue equals marginal cost, which was right there, we got our output of 6 right here. We go up to the demand curve or the price line to find the price that the monopolist wants to charge, which is 15. That's the average revenue. And we happen to see that the average cost curve is below that price. So we know they're making profits. But what if the average cost curve, let's just move it, what if AC was actually up here? So this is a little busy to see, but this AC is no longer there. But what if the actual average cost was up there? Then we'd find the optimal quantity of 6, go up to the price line or demand curve to find the price they want to charge, but then realize that their average cost is way up here. So if I brought that across, the average cost is 20. So their price of 15 is below the average cost of 20. So they're losing $5 per unit. In this case, times 6 units, they're losing $30. So it depends where that average cost curve is that will determine whether the monopolist is making profits or losses. Now you might think, why would a monopolist make losses? Why would they allow themselves to make losses? And the answer is they usually wouldn't, but there are situations if a monopolist is a government sanctioned monopolist and they're proving that they're losing money, the government might subsidize them to a certain point and let them continue production because it's a necessary service, like public utilities and things like that. So there are some cases where a monopolist could show that they're making losses, but then something would have to be done about it because they wouldn't stay in the industry and continue to make losses. It wouldn't make sense. But keep in mind, you find your profit maximizing quantity, where MR equals MC. You find the price that they're going to sell that quantity at, directly from the demand curve. And then you have to go to the average cost curve to see what that number is to determine how much profit that they're making, or occasionally how much loss they're making. So that's the end of this little segment. There's a few more slides in the chapter you can look at that just goes back to doing an example of total revenue minus total cost. But after this, we're going to go into criticisms of monopolies and compare monopoly to perfect competition, and then look at some good things about monopolies. And we'll see you when we get there.